Okay, how's everybody doing today? This is what I got today. I got a battery light on and it says check charging system. This is a 2008 Ford Taurus. Let's see what we got. All right, so we got a 2008 Ford Taurus. As you know, you saw I've got a charging light. I've got the error code that comes up, which indicated to me that I had an error code probably in the PCM, and that's what I found. So found this error code stored, P625. It's early in the morning, sorry, thinking. It's telling me that the generator field terminal circuit is low. So already got the schematic. I've got some service manual information, but just like you, I want to get to everything really quick and do some quick tests that I know to verify some things right off the bat. So here's my schematic. You've got a battery. You've got your 12 volts here, which goes to the starter. It also goes through two fusible links. Those could be open, not sure. Our alternator, generator, depends on what part of the service manual you look at when you see that information. So that's one path and then to ground. Then you've got another signal path here, 12 volts, through a fuse. We could check the fuse, but I think what I'm going to do is maybe back probe this connector because we're doing a lot of work here. I'm thinking this is where my problem lies. If it's not the alternator, I'm hoping it's not my PCM. But basically, the error code is telling me that I've got something going on here where my alternator either isn't receiving the signal from the PCM or it's not sending a signal to the PCM. So the first thing I'm going to do is I'm going to check my voltage here. Without the car started, I'll show you that in a second. Then I'm going to start it, and typically, once the car starts, if this is working correctly, your voltage, your battery voltage is going to be about 1.5 volts above your battery voltage when you measured it when the car was just sitting. From there, we'll do some different things, but that's what we're going to do next. Okay, so this is what we're going after. So we're going to take a measurement from here to here. That should be at least 12.2 volts. That's what we're going to do next. Red, black, we've got 12.3. So good news, looks like the battery's okay. So the next thing I'm going to do is start the car, and this thing should jump up to somewhere between 13 and 14 volts. Give me 1 second to do that. Okay, so the car's running, as you can hear. Let's take that measurement now. That's not good. So either the alternator's not working or the alternator's not getting the signal it's supposed to get. So we're going to have to take a look at our schematic and see what we need to look at. Okay, so next thing I want to do, this is part of the pinpoint inspection, but I want to do the things I can do quickly. I'm actually going to check if there's a voltage drop across this battery cable here, from battery terminal plus all the way through, all the way down, and then on to C102B. That's on the alternator. If I have a voltage drop here, something greater than 500 millivolts, then that tells me I have resistance in the wire and I got a bad connection or a bad wire. So I'm going to do that next. Let me get the camera position for you. So here's our alternator. It's sitting down there. The connection we're going after is right there. I've already popped off the cap. I'll just okay, so again, our connection's down here. There's just a plastic cap that sits on top of this. I know this is tough to see, but there's a plastic cap. It just pops off. So it doesn't matter the polarity of the wires, your test leads. All I want to do is make one connection at that connection down there, and then the other one at battery positive, 12 volt positive on your battery again. So touching this, touching that, we're good. We don't have 500 millivolts or greater, so that tells me the cable's good. Next thing I'm going to do is I'm actually going to battery ground. That should have battery voltage on it, and it does. So next step, we're going after a different connector, which is where I suspect the problem is, and we'll see what we find there. Okay, so before we do any troubleshooting, again, I'm going after the quickest stuff, but I'm going to give you some tips that, if you have a scan tool, if you have the service data, and even if you don't, I'm going to show you some of that information, you can do if this doesn't work for you. But again, what I'm doing is the simplest way possible. So we have already checked the battery voltage. We know it's good. We've checked this line right here. We know that's good going to the alternator. The error message that we're getting, again, is at P0625, that the generator is low. So with my scan tool, I was able to look at some of the PIDs. And what you're going to find here is I had fault generator command line. That's good. So there's no fault. That particular connection, sorry, I'm trying to do this slow for you, is right here. The signal from the PCM telling the generator, based on the voltage it senses, that I need to kick up the charge or reduce the charge. It's telling us that that particular pin is good. As we scroll on down, it says monitor of generator 1 is low. That's this connection right here. So if I wanted to, and I was doing an education or a teaching on this, I would back probe this, and I would take some measurements based on service data, which I'll show you in a second. But for me, I'm going to basically unplug this connector, inspect it, see if there's anything going on in here, and then we'll reconnect it and see if our voltage comes up. If it doesn't, then we're going to continue on with this video and try and just rule out the alternator before we call it dead. Again, I'm hoping it's here. We're going to find that out. Now, with service data, what it's going to tell you to do with your scan tool, and again, this is a pinpoint test, is it's going to bring up the following PIDs so that you can monitor different conditions when you're putting it through its paces. And again, I just did a live data shot. I didn't configure this to have them all. If we were doing that, I would do that. And if we have to, I will do that. But basically, we'll be looking at this one. We'd be looking at this one. We come down here. We look at the frequency of the generator, the monitor again. We'd be looking at the desired voltage, which is 12. This is also telling us another fault in the generator monitoring line. And then as we keep going and scrolling through this, they'll give us a measurement, the percentage for the duty cycle. And for some reason, maybe I have missed it. Right there. So command of generator. So this is the duty cycle. This is going to tell it to do something. And right now, when I had it on live data, it was actually telling it to do something. Again, that's this command line right here. So right now, what we'll do is go back to the car. We're going to disconnect this connector. We're going to do a visual inspection. If there's anything going on, we'll clean it. And then we'll reinsert it and, see if our voltage comes back up. It should come up 1.5 volts. If it doesn't, the other thing we can do based on service data is we can take some measurements at that connector location. So you'll notice it's C102A, 1, 2, 3. It actually has our colors called out and the signal pass, and then what we should see. So on pin 102, number 3, if we come back here, here's number 3. That's our battery voltage right here. So we could have a bad fuse, but I suspect not, because it looked like the command line was actually working. So that tells me voltage is getting in. I'm just crossing my fingers it's not my alternator and it's this connection here. So if we want to double check the output command line from the PCM, that's pin 1. We should see between 8 and 11 volts. And that's our command line. Give me 1 second, double check this. Pin 1. Pin 1. That's interesting. Service data is telling me this is the command line, even though it says monitor on my schematic. Unless I'm losing my mind, that's interesting. It says pin 1 should be 8 to 11 volts. So hopefully we don't have to go down that path, but process of elimination would tell me that if I make these measurements, regardless of these pin numbers, I should see one of the pins should have 8 to 11 volts. One should be 0 volts, because that's I believe it's our ground path through the alternator. And then one should have the battery voltage, our sensing voltage. Okay, so let's go back to the car. Give me 1 second. Okay, before we do any cleaning, next step I want to do is I actually want to check the PCM. So based on service information, these are the connections we're going to have to C102A. I've disconnected it. That's 102A. I'm going to measure the voltages on these different pins. So 1 should have battery voltage. Again, sorry, get this thing zoomed in. Trust me, it goes all the way over to the battery. The next one of these, and this is where we have the confusion. I've double checked service information. It conflicts with what this says, but one should be 0, one should be 8 to 11 volts. So make sure, and this is important, so key is on, but engine is not running. And then I'm going to ground to the battery terminal negative, and then I'm going to use my probe to actually back probe in the harness. And we'll bring my voltmeter over here, hopefully so you can see this right there. So car's in the on position. Again, one of the pins, I got 12 volts, so that could be my battery. I got 11 volts there. Perfect. So PCM's working. And I got 0 volts there. Awesome. So let me come right back. Give me a second. So what does that tell us? That tells us the signal from the PCM going in is actually working. So next step, I've killed power here with my key on. I'm going to use some contact cleaner. This is contact cleaner I use. I like it. Maybe you. Whoop, here we go again. Get a better tripod. Okay, so I'm going to try and do. I don't know how much of this I have, but I'm going to spray some of these connections. And I do have a brush around here somewhere. Basically just want to brush this out as best we can. Now, what I could do, let me grab my camera, is these connectors, as you can see, are in there. So you could, there's 2 holes. Sorry, I'm trying to do this with a couple hands. Give me 1 second here. From this side, you'll see there's a metal pin in there. You could push it to the left. I don't want to do that just yet, but if it's not compressing down below, it's not making a good contact, that could be generating our issue right now. So I'm not going to do that yet. I'm going to clean this connection, and then I'm going to clean the connection that we got down there on the alternator. And then what I'm going to do is plug this back in again, and then we'll measure our voltage and see if that helped. If it does, then maybe I'll throw some dielectric in here or something to promote this connection a little bit better. All right, let me get in there. It takes a couple hands to do this cleaning, but I'm going to clean out that connector, and we'll be back. All right, I've cleaned out my contacts. Word to the wise, this is an insulator that added 15 minutes to this job. So when you're using compressed air to blow out that connection, be careful. So I'm just going to try and get this back in there, and hopefully I don't drop it again. Should have did it with my fingers instead of a pair of needle nose, but yeah, it's a little funky. This is why it was difficult to get the connector out originally, because of this rubber seal. I'm very sure of that. So I think I got it in backwards. I don't know if there's a specific way. I'm looking at it. Yeah, I think I had it upside down. So there is, on the bottom side, there's more of a gap than on the top. So let's see if we can get it in this direction. Yeah, she just wants to fly. It's not in there perfectly yet. Now it's good. Okay. Hopefully you guys can see that. Give you a better angle. Yeah, sitting in there flush now. So next thing I'm going to do, make sure I'm dry on this end, which it looks like I am. Reconnect this, and I want to be really careful because of the rubber seal. And you should hear a click just like that. So let me get set up. We're going to measure our voltage, and we're going to see what happens. Hopefully this did it. All right, so let's hook it up. We're measuring battery voltage right now. It's at 12.2. So bad news for us. So what we're gonna have to do is check the alternator. So I gotta disconnect the battery. To do that, we're gonna make some resistance checks. I'll show you that in a second. All right, so let's move on to the next test. So service data is telling us to check the alternator. We're gonna make resistance values, confirmations of resistance values. So what we're gonna do is we're actually gonna disconnect C102A from the alternator, which is down below, and I'll show you that in a second. We also want to come over here and disconnect the battery positive terminal because we don't want any power going to the system because we're doing resistance checks. We're going to ground our digital voltmeter to the negative side of the battery. And then, like I said, we're going to come down here. We're going to hopefully keep the camera where it belongs. We're going to disconnect our connector, if we haven't already, C102A, which is that, from the actual alternator, and we'll make some resistance checks. So that's what we'll do right now. So the first check it's saying to do is check the generator B plus resistance. So we're going to go from C102B. It's going to be that connection right there. That's our battery positive connection over here. But we're going to check it right here at the alternator. And that value, if it's greater than 125K, then we're going to go to B20 and we'll make some resistance checks. If it's not, then we're replacing the alternator or the generator. So we're going to measure this value. If it's greater than 120K, we're going to the next test. If it's not, we're replacing the alternator. So going down to 120B. 102B, sorry. Yeah, that's not good. Okay. So you can see here, we're measuring about 2.5K, not greater than 125. So if the resistance value isn't greater than that, which it isn't, we are replacing our alternator. Now, for those of you who get to this test and this works, and you go on to the next one, I'll do that one next just so you can see it. So now what we're going to do is we're going to make our resistance checks here, but we're actually going to do it not on the harness side, but on the alternator side. And basically what we're looking to see is if these are less than basically 1K. So this, the lowest value we have is 1K on pin 1, and the other two, it should be greater than 125K. So they all should be greater than at least 1K. So there's pin 1, it's greater. There's pin 2, that's greater. And there's pin 3, that's greater. Okay, so alternator needs to be replaced. All right, so I went over to Riley's and picked up my brand new alternator. I had to turn in the core, so I don't have the box, but this looks like the part number that's on it, the specs. So I was doing some resistance checks, and I wanted to do them with you guys so you could see this. The first one I'm going to do is that B plus resistance check. Remember, that says it should be above 125K without banging the camera. So basically, we're going to ground to the alternator. I'm going to go to the center pole of the battery plus. And right now, what you'll see is that it's actually fluctuating, which tells me there's some capacitance and possibly a diode in there. So interesting enough, it's above 125K. So our other one was, I think it was like 1.3K or something like that, but we can rewind the video. What's interesting is when you switch the polarity, like this, you actually get 30K. So I want you to be aware of that fact. This is a brand new alternator, and that's how it functioned for me. Again, I'm going to go back to my positive lead being here, my negative lead. I'm just going to go on the ground, on the stud itself. You'll see we're good in that direction. Now, for the other tests, I'm wondering if I could actually do this with the alternator out. So that's what I'm going to do next. All of these tests should be above 1K. So I'm going to go to the, to the stud again. I'm going to go to pin 1 or pin 3, whichever one it is. This says 60K. There's already a difference. Yep. This one's showing 60K. And this is basically an open connection. So definitely some differences already, leading me to believe that we've got the right part. So let's go ahead and install it. Okay, here we go. So battery voltage is 12 right now. It's low because the battery needs to be charged. I've got some PIDs set up just to monitor and see what's going on. I've already cleared the codes. I'm guessing these things that are telling me there's a fault and there's something low, it's just because I haven't run the vehicle and gone through the drive cycle. So let's fire it up. Fingers crossed that this thing goes up to 13 or 14. Well, that's good news. So, right where we want to be, 14.3. Like I said, I'm guessing with these PIDs, I'm going to have to go through a drive cycle and see what we can get. But for now, if this video helped you, and there's a couple of them, one how to replace the alternator, and then this one here that we're trying to do a troubleshoot, replace, and then confirm our repair. Everything seems to be going okay. One thing I didn't mention is make sure that your serpentine belt is installed correctly on all the pulleys. You definitely don't want that bolt coming off. If this video helped you, hey, give me a subscribe, give me a like. And if it didn't, or hey, I could do something better, I'm definitely open to that. So for now, you guys have a great one. We'll talk again.